Hello, students. In this lab, we're going to look at the combination of a parallel circuit with a series resistor. So we have three resistors. Two of them are connected in parallel, and then the third one is connected in series to that. So here is the circuit on paper. Take a close look at this. Now, in the first part of this lab, the battery must not be connected. I have connected the whole circuit, but as long as you do not keep the switch pressed down, that would mean that the battery is not in the circuit, okay? So in the first part, we're going to measure the resistances, and here we're not going to keep the switch pressed down. So the multimeter should be put in the resistance range now. Let's put it on 2 kilo ohms. And we're going to measure R1. So remember, this is R1, this is R2, and this is R3. Even before that, be careful with the connections because you have a lot more wires here. You got to understand that R1, you can see R1, this cable connected to this, another cable connected here, okay? And then you have R2 and R3. From this point, you have a cable going all the way to this, which is what, S3. So S1 to S3. And then you have another cable from S2 to S3. So S1 to S3, S2 to S3. And then you also have a cable from S5 to S6 and S6 to S7. Yeah, S5 to S6 and S6 to S7. You also have another cable connecting the negative of the battery all the way to the other end of the resistor. So that is not going to be useful in the first part. That's only in the second part, but just remember all of these wires are connected. Now, first to measure the resistance R1, all we got to do is just remember there's no positive and negative for resistors, so you can either put it here or here and look for the measurement. That is 0.099 kilo ohms, which is 99 ohms. Now, to measure the resistance of the parallel combination R2 and R3, you go here or here, it doesn't matter. I'm just touching it there, let's see. And then you get 0.244 kilo ohms. Make sure that the contact is tight. 0.244 kilo ohms. That is the resistance of R2 and R3 in parallel. Now, if you want that total resistance, so the resistance of all three of them, then you got to have it here. Between these two terms, I hope you can see it, and I hold it there, and it's 0.344 kilo ohms. So that's how the resistances are measured. Next, we're going to measure the voltages. The measurement of voltages are exactly done at the same points. The only difference is that now you got to have the battery in the circuit. And since we already have the wiring done, all you got to do is, all right, to find the voltage across R1, now be sure that this is on the negative. Why? Because this cable goes to the negative of the battery, and this is on the positive, okay? Keep it there and press down the switch. Oh, move this to voltage. 20 volt, I think, will work. Yes, and you get 0.9 to 0.93 volt. That is the voltage across R1, which is V1. Now, to measure the voltage across 2 and 3, this is the negative and this is the positive. And so, make sure that the cables, none of the cables come out. Okay, and then press down the switch and let's see. All right, so that's like 2.28 volt. And then to measure the voltage across all three, which is V1, 2, 3, put it here, right? Okay, you can see that, and then press down. So you get 3.21 volt. So that's how you measure the voltages. Finally, we have to measure the currents. Now, this is the hard part in the sense that whenever you measure current, the meter must be put in series. So that means we have to remove the cable from there and include the meter exactly where you have removed the cable. For example, if you want to measure I1, you're going to remove this cable. You see this cable? That is between what, S6 and S7. So if we remove that cable, which I'm doing right now, keep it there because we need it. Put the multimeter on 200 milliampere DC, of course. And then you have to be careful about the positive and the negative. Okay. So you know that we've removed this, and this end is connected to the negative. See, this cable, make sure it's tight. This is connected to the negative. And so we're going to put the negative here, either here or here. Okay, it's the same thing. Put that there and include the positive here. Okay, and do not forget to keep the switch pressed down, and you get 9.2 milliampere. Remember, that's 9.2 milliampere. Now, before you measure I2, remember to put this cable that you removed back in place. So that is what is very important, and that's something that students forget. So put that cable back like I'm doing now. So put it back, and whenever you connect, try to have 2 points of contact. Okay, 2 points of contact like that. And I2 is the current that is flowing through this part. So we're going to remove this cable between S2 and S3 carefully. I'm removing that cable now between S2 and S3. And I'm going to insert the multimeter. And here I have the multimeter. So why do I have this positive on this end? Because, see this cable? It's connected to this second point on the switch, and it comes from the positive of the battery. So through the switch, this cable is, so that makes this positive, makes this also positive. That's why I have the positive here and the negative on the other end. And press down and you get the current. Remember, it's in milliampere, so that's 2.2 milliampere. And right now I'm putting that cable back that we removed. So you can put it here. You know, these are the same. So I put that there now. And I3 is the current that flows here in this part. So in this part. So that means we have to remove the cable from S1 and S3 like I'm doing now. So I remove that cable. I have again included the meter with the positive on this side and the negative on the other side, and press down on the switch and take the measurements. It's 6.9 milliampere. That's what I get. Okay. Now take note that I had put back that other cable between S2 and S3, this cable. So don't forget that. So finally, we're going to measure I4, but before that, put back this cable that we removed. I keep repeating this because this is the part that students forget. You have to put those cables back. And since I4 is the current flowing through this cable, which is connected between SW2 and S4, I'm going to remove that cable. Right, that's gone. And I'm going to include the meter now. Well, of course, the meter should have the positive here because that's where it's connected to the positive of the battery through the switch. And the negative could either be here or here. So let me put it here. And press down on the switch. And you get the current as 9.2 milliampere. Oh, you got to measure one more current, which is called I naught. So let's take the meter out. From there, remember to put that cable back as I'm doing. Cable back. Don't forget that. And when you're removing and inserting cables, make sure you don't break any other connection. And I naught is the current that flows through this cable now. Do you see that cable? This cable that connects the negative of the battery to, what is that, S8. I've removed that. And of course, when you measure, since this is the negative, you're going to put the negative of the meter there and the positive either here or here or here. You've got three options now. Okay. Put that there and measure the current, which is 9.2 milliampere. So that's how you measure the currents. Yes, so that is it. We made the measurements of resistance, the measurements of voltage, and the measurements of current. This is the most complicated lab up until this time, but you would not feel it so hard because we have progressed slowly through different circuits. Be careful with the connections. Make sure that they are neat and tight. Follow the instructions. You also have the manual with you. And on top of that, you have the video. But if you still have any questions, you can write to me. So this is where you're entering the values. So table 1, you look at the colors, enter the resistances, and then the coded resistance, the tolerance, and you got to measure each resistance with the meter before you start the lab. That's what goes there, the percentage error. And then table 2, that's where I started showing you how to measure the resistances. That goes in this table. Table 3 is for voltages, and you have them side by side. Again, you kind of take this and put it down here so you're able to compare something, which you will see in a minute. And then you also have the measured currents, and you have to calculate the current. How do you calculate the current? That's where the circuits have to be simplified, and you have to calculate each current and find the percentage error and then turn in the lab report. Also, do remember that this is the circuit that we've been using in this lab, R2 and R3 in parallel, R1 in series, exactly as shown here. Here are the formulas. You can use these formulas to calculate the currents. If you measure I2 and I3, the sum of those two should give you I23, simply because the current that flows through R2 and the current that flows to R3, they combine and flow through R1, which is the same as the current flowing through the battery. So that's why you have all those formulas. But then when it comes to voltages, for any electrical components connected in parallel, the voltages are equal. That means the voltage across R2 should be the voltage across R3. Same. That should be the same. That's why you have the equation number 3. And to get the total voltage, which is the voltage provided by the battery, you got to add the voltages across R1, which is V1, with the voltage across R2 and 3, which is V2, 3. So that's why you have all those formulas, and I think if you look at the manual carefully, you will get this, and you should be able to do this lab without much of a problem, okay? Just follow along, and I hope this was useful, and I'm going to, try to help you out with pictures and all that stuff attached to the real-life circuits, and hopefully it'll be good. Thank you.